Okay, so in this section we talk about the hyperbola. So this conic is similar to an ellipse, like in its equation and really in its philosophy, I guess. I mean, it's created by two fixed points called foci, and with an ellipse you can imagine like the branches, the left-hand branch and then the right-hand branch opening toward each other. In a hyperbola, these branches open away from each other. So just sort of going over the picture here. So again, F1 and F2 are the foci. This segment that begins at A1 and ends at A2 is the transverse axis, and the endpoints of the transverse axis are called the vertices of the hyperbola. This segment from B1 to B2 is the conjugate axis. This is the axis that does not contain the vertices. The branches, these things that kind of look like parabolas, they may be horizontal or vertical and are controlled by oblique asymptotes. In other words, these slanted lines control the narrowness and wideness of the branches. And so if the branches open horizontally, we're talking about an equation that begins with x squared. So here we have x squared over a squared minus y squared over b squared equals 1, and we notice that it's very similar to the equation of an ellipse. The ellipse has a plus. The distance from the center to either focus, which is called C, is given by c squared equals a squared plus b squared. Recall that in an ellipse, that was c squared equals a squared minus b squared. So very similar to an ellipse, the vertices here are plus and minus a0. Note that the vertices come from the number occurring under the leading variable. And the asymptotes have slopes plus or minus b over a. We don't really need to memorize that fact in abstract. I mean, we can come up with that on a case-by-case basis. Now, if the hyperbola opens vertically, meaning the branches would go like up and down, then instead y is the leading variable. So you'd have y squared over a squared minus x squared over b squared is 1. You still have c squared as a squared plus b squared for the foci. This time the vertices, instead of being plus and minus a0, are 0 plus and minus a. So in this first example, we're going to find an equation of the hyperbola with vertices 0, negative 4, and 0, 4, and foci 0, negative 6, and 0, 6. Now, strictly speaking, we're not asked to sketch this hyperbola, but it might be instructive to do so. And I don't even mean a good sketch, just something crude so that we can see what we're working with. So the vertices are 0, negative 4, and 0, 4. And the foci are at 0, negative 6, and 0, 6. So the fact that the vertices are vertical with each other tells us that this hyperbola opens vertically. The key features, the letters we've learned here: A is 4, that's the distance from the center at 0, 0 to either vertex, and C is 6, that's the distance from the center to either focus. Now, our goal is to find the equation of this hyperbola, which means we need b squared. I know a squared is 16 now, so b squared can be found by saying, well, c squared is a squared plus b squared, and then, well, c squared is 36, since c was 6, a squared is 16, since a is 4, and so we can say that b squared is 20. Now, since the hyperbola opens vertically, we're looking at a y squared over something minus x squared over something equals 1. Since it's vertical, y is the leader. Well, we went up and down by 4 to get to the vertices, so underneath y squared must be 16. That's a squared. Underneath x squared, we would have 20. That's what we just found for b squared. And so this is the equation of this hyperbola. Going on to the second page, in this example it says, for the hyperbola given by 9x squared minus 16y squared equals 144, find the vertices, the foci, and the asymptotes, then graph the hyperbola. Probably to get a good graph here, or to get any graph, we should put this in the so-called standard form, which means let's divide by 144 so that the right side says 1. 9 goes into 144 16 times. 16 goes into 144 9 times. And then the right side is 1, of course. Now, 16 is a squared, 9 is b squared. The first number is a squared, the second is b squared. And so right away, this tells us how we can sketch this thing. Like it says in the instructions, find the vertices, the foci, and the asymptotes, then graph the hyperbola. But I think it's probably easier to get the graph first and then find those other things in a minute. So because a squared is 16 and it's underneath x, that tells us that I'm going to go left and right by 4 from the origin to get to the end of my transverse axis, the one that contains the vertices. Because I have 9 underneath y squared, that tells me I'm going to go up and down by 3 to get to the endpoints of the conjugate axis, the one that doesn't contain the vertices. Now, as far as trying to sketch the hyperbola, the tricky thing is that we don't know exactly how wide the branches are when they open. So to figure this out, what I'm going to do is I'm going to create a box that passes through these points that I graphed. Now, the asymptote lines that control the width of the branches pass through the center, so pass through 0, 0 in this case, and they connect the corners of the boxes. So like there's one of my asymptote lines. The other one connects the other corners. Now, because x squared leads this equation off, that tells me that the branches open left and right because x is a horizontal variable. And as I go off to the ends on the left and right, my branches should get closer and closer to the asymptote lines. So I have something like this. Now we can see the vertices explicitly. So I can see that the vertices are plus and minus 4, 0. That's where the branches are closest together, you could say, I guess. As for the foci, well, c squared is a squared plus b squared. So c squared is the sum of the denominators, 16 and 9. Whatever order we write those in, it doesn't matter because we're adding them. So c squared is 25, and therefore c is 5. The meaning of c equals 5 is that we start at the origin and go left and right by 5 to get to the foci. After all, the foci should lie on the transverse axis. In other words, they should lie on the same axis as the vertices. So our foci are at plus and minus 5, 0. The last thing we find are the equations of the asymptote lines. So they both pass through the center, which is the origin, excuse me. So the asymptotes pass through 0, 0. The other defining characteristic of a line is its slope. Well, let's see. For the upward opening line, or the upward pointing line, well, let's see. If we start here and go to the corner of the box, we go up 3 and right 4. So one of the slopes is 3/4. For the line that points downward, we go down 3 and right 4. So its slope is negative 3/4. In other words, we have slopes of plus and minus 3/4. Well, we know b is 0 because the y-intercept is 0. So I would say the equations of these lines, plus and minus 3/4 x plus 0. That's mx plus b. For the last example in this section, it says for this hyperbola given by 4y squared minus x squared plus 24y plus 4x plus 28 equals 0, find the center, the vertices, the foci, and the asymptotes, and then draw the graph. So this equation is totally unorganized. So we're going to try to fix that by completing the square. So to complete the square, we would like to have the y's next to each other, the x's next to each other, and anything else over on the right-hand side. The other preliminary step for completing the square is we need to have coefficients of 1 on x squared and y squared, and right now we don't have that for either one. For the y's then, let's factor out a 4 so that I have a 1y squared. And for the x's, let's factor out a -1 so that I have a 1x squared. The selective factoring isn't cheating. If we redistribute, we still have the same equation we had before. 4y squared plus 24y minus x squared plus 4x equals -28. The way we complete the square now is we break up the numbers in front of x and y. We're thinking of those as the middle numbers of a perfect square trinomial. 6 is 3 plus 3, -4 is -2 plus -2. Then we say, well, 3 times 3 is 9, so we're going to add a 9 inside the parentheses. And -2 times -2 is 4, so I'm going to add a 4 inside the other parentheses. Now, I have to balance the equation, but let's be careful. I haven't added 9 to the left side. I've added 4 times 9 to the left side. In a similar way, I haven't added 4 to the left side. I've added -1 times 4 to the left side. So next, well, y squared plus 6y plus 9 was created by 3's, so I have 4 times y plus 3 squared. X squared minus 4x plus 4 was created by -2's, so I have x minus 2 squared. And if we add up the terms on the right side, we get 4. That's -28 plus 36 minus 4. The last thing we'll do is we'll put this in the standard form so that we can see how to graph it. So if I divide everything by 4, and I'm doing this because the right side is 4, okay, so dividing everything by 4, I get 4's canceling here, and I'm going to go ahead and leave the 1 as the denominator so I can clearly see what number is a squared. I've got x minus 2 squared over 4, so that's b squared, and 1 on the right side. So right away, like I have no hope of graphing this if I can't say what the center is. I need to know where I'm going to start this thing. Well, the number by x, the opposite of this number is 2, and the opposite of the number by y is -3. So I have a center of 2, -3. Okay, so to graph this thing, so I'll go to 2, -3, and let's see, underneath y is 1. So if a squared is 1, then a is 1. Since this is underneath y, that means I'm going to go up and down by 1 from the center. Underneath x squared is 4, and so because that's underneath x, I'm going to go left and right by 2, the square root of 4. Now I'm going to create my box that goes through these points. And my asymptote lines are going to connect the corners of this box. Because y is the leading variable, that means I'm going up and down with my branches. And as I go off to the left and right edges of the graph, the branches are going toward the asymptote lines. Now, the vertices can be seen plainly. The vertices we see, well, let's see, if we start at the center, if I go up 1, I'm at 2, -2, and if I go down by 1, I'm at 2, -4. For the foci, well, c squared is a squared plus b squared. And so c squared is the sum of the denominators, 1 and 4. And so c squared is 5. And therefore c is the square root of 5. Since the parabola opens vertically, this means that starting at the center, 2, -3, I'm going to go up and down by this amount. And so my foci, starting at 2, -3, I go up by square root of 5 and down by square root of 5. To sketch these, square root of 5 is about 2.2. So from the center, I'll go up by 2.2-ish. And from the center, I'll go down by 2.2-ish. The last thing we figure out are what are the equations of the asymptote lines. Well, the asymptotes pass through the center, so they pass through 2, -3, and have slopes. Well, let's see. Starting at the center, to get the upward pointing line, I go up 1 and right 2, so that's a slope of 1/2. To get the downward pointing line, I'd go down 1 and right 2. So that's a slope of -1/2. So my slopes are plus and minus 1/2. It's going to be a chore to put these in y equals mx plus b form. We're going to have two separate equations that look different. Typically what we do when the center is not the origin is we just write the equations in point slope form. So that's y minus y1 equals m times x minus x1. Well, y1 is -3, so I'm looking at y plus 3, because y minus -3 equals plus and minus 1/2, those are our slopes, x minus 2. And we typically leave it this way. This way we can unify the equations of those lines in an easy way. If I were to try to write them both in y equals mx plus b form, we would just have two separate equations. It kind of unifies them by just doing this. And that's hyperbolas.